Hi, and welcome back to Algebra 1. Today we're going to look at how to use our skill of evaluating variable expressions to help us with some application problems. So these questions are going to be a little bit more specific than just simply taking out a letter, putting in a number. Although that's the math that's going to help us evaluate to get our final answer, we're going to be asked something specific that's going to need a label associated to it when we're done. So make sure you have that label attached when you're completely done doing your problems for today. You're going to want your notebook from your binder, not your note packet for today, because these are in addition to the examples that we had in our binder. So if you're at home learning right now, you need your notebook, not your note packet. You could have your note packet there if you need it to help you, but these are additional examples that don't have space in our actual packet. All right, so starting with our picture number 1 here. I don't think you need to draw anything in your notebook, but it's a scenario where we have an angle, and we're asked to solve for the measurement of angle A. This little M in front of an angle sign is just asking us, what is the total degrees of that particular angle? So in this case, it's saying, what's the total degrees of the angle up here that we called angle A, which is angle A just means the vertex point of that particular angle is AA. That's it. So we want to know how big is this angle here in degrees. And the expression 12x plus 15 describes the size or the degrees of that particular angle. So we want to evaluate that problem, 12x plus 15. To be able to evaluate, we have to have a value of x to substitute in. So we're creating the whole math problem here. We can't just put 12x plus 15 because we'd be stuck. We need the when portion of our problem. So when, and we're told x is 11. So that's step 1, creating the whole evaluate when problem. All right, now that we have the problem, we can actually do the math. This x is out, and this 11 is going to go in its place. Hidden operation here of multiplication, because we have a number right next to 11. So make sure you substitute that in also. And then once we get here, it's please excuse my dear Aunt Sally, PEMDAS to evaluate to get our measurement. So a 12 times 11 first, multiplication before add. So we're going to start here. So a 12 times 11 will give us 132, and we still have our plus 15. All right, we're going to finish by adding here 132 plus an additional 15 to get 147. Now we're solving for the measurement of an angle, which is in degrees. So our label here would be a circle that looks like that for degrees. Or if I'm typing, I would have to write out the word degrees. Good final. I can go back and kind of check to see how reasonable my answer is. That measurement, 147, describes the measurement of what's called an obtuse angle, meaning it's larger than 90 and less than 180. So I would go to my picture and I would say, if I were to describe the type of angle, would I describe it as obtuse? If I wouldn't, if this was small and acute in size and I got 147, I know I made a mistake somewhere in my evaluating process. Use that as a method to check your work. All right, number 2, we want to know the measurement of angle ABC. Now, here's where you need to be careful. This particular picture has 2 angles, or really 3 angles. There's these sort of inside angles here, and then there's this one big sort of what looks like right angle on the outside. So I need to make sure I'm evaluating the right portion of the picture based off the description. So this says start at A, go to B, and at C. It only wants that particular wedge of the picture. So if I'm going to start here at A, I go down to B and up to C. It means it wants this portion, not this portion of the angle. So we're not using the 10x expression at all in this case. It wants us to evaluate 5 times x plus 9. If all I write is that, I'm stuck. I can't evaluate until I know the when x equals part. So in this case, when x equals 3, which is given to me up here. So make sure I finish that whole problem. All right, x is out. 3 is in its place. 5. Hidden operation here of multiplication, number right next to parentheses. I'm going to add that in. And then 3 plus 9. All right, order of operations from here because it's all numbers. So we'll go 3 plus 9 next, 5 times. 3 plus 9 more would give us a 12. Finish our multiply here, 5 times 12, which would give us a 60. And it's an angle degree, so don't forget your label of degrees. So I go, all right, this is an acute angle. And I would say this portion of this picture is an acute angle. They match, they seem reasonable to one another. All right, this says if x is 5 and y is 2, what is the length of the rectangle? Now, I need to know some basic vocab here, which is which one is the length? Because I have two expressions here. One that's 10y and one that's 4x plus 16. And I want to know which one am I actually evaluating because it's the length of that particular rectangle. So the thing I have to remember about rectangles are that they have lengths and they have widths. The length is the bigger piece, the width is the shorter piece. So I would go to my picture and I would say, all right, is it this side piece or this bottom piece? Which one is the longer piece? Because that's the one it wants me to do, the longer piece called the length. And in this case, the way the picture is, it's the bottom piece, which is 4x plus 16. So this problem is asking me to evaluate 4x plus 16, not this 10y. So I have to know the basic vocabulary of a rectangle to get started here. And then I also need when my x equals something, which was originally given to me as a 5. All right, we now have our whole problem. We can take x out. We can substitute our 5 in, and we can evaluate. So 4, number right next to the letter, the hidden operation is multiplication, times 5 plus 16. All right, all numbers now. So it's PEMDAS the rest of the way. 4 times 5 would give us a 20 plus 16. When we add here, we'll end up with a 36. And our label, which is given to us up in the picture up here, is that this particular rectangle is being measured in inches. IN if you would like to abbreviate. All right, this one's a little bit tricky because I have to know again which portion of the picture is it asking me about because I'm only using that particular expression to evaluate. So I want to know, am I doing sort of this bottom angle here, which would be 11m plus 4? Are we doing this bottom angle here, which means I would be evaluating 8m? Or does it want us to evaluate this top angle, which would be this 10m plus 2? It's not asking for all of them. It's asking for one specific measurement of one of those angles. So I got to look at the description, which is what's the measurement of angle ABC? Or start here at A, go down to B, and over towards C. Right? That angle right there, which is this guy right here. Which means I don't need this one, and I don't need this one. It wants that bottom corner angle. So all I'm evaluating is the 11m plus 4, which means I need a m amount to substitute in, and I was told that m is 6. So now I have my whole problem. I'm evaluating 11m plus 4 when m has a value of 6. So m's out. Number and letter right next to each other, hidden operation of multiplication. And now all numbers in the problem, PEMDAS is our approach. All right, so 11 times 6 would give us a 66, plus 4 more would end up giving us a 70, and it's in degrees again. Good, final. And I go to my picture, all right, that's an acute angle, but it's a pretty big acute angle. And I'm saying, yeah, this is straight up here would be 90. We're pretty close to that. It seems reasonable to be 70 degrees. All right, last one. It wants us to evaluate or figure out what the diameter of the circle is. And we're told that the piece in the picture that goes the whole way across and through the center is 7b feet. Now, here's the tricky part about circles, because I could be asking you to evaluate for a radius or a diameter. And I have to know which one's which. So right now, this piece, it goes the whole way across and passes through the center. It's called a diameter. However, I could have given you that same picture and asked you to evaluate for the radius. You just have to be careful. All right, so let's start with the way the question is being asked. How big is our diameter, which is what's in the picture and being described with the expression 7b. So we're going to evaluate 7b when our b value is 9. All right, b is out, 9's in. Number right next to the letter, hidden operation multiplication, put it in there. And PEMDAS from this point on, there's one thing to do. So 63. And our label here is feet. So that's what we would attach to our answer. Now, if this same question was given to us, but asking us for the radius, all right? So let's say this now said radius. Then when I get here, I would have the whole way across called the diameter. And I wouldn't want all that. I would want the radius, which is just halfway across, or half of this piece. And I would have to take this 63 and divide it by 2 to finish up. right? It would take 2 additional steps to get what only half of that piece is, so be careful. And now when we take our 63 and we divide by 2, we would end up with 31.5 feet. Right, so this would answer the question if it was a radius question. This is the one that would answer the question if it's a diameter question. Now, here's where you also need to be careful. I may have only given you the radius here and asked for the diameter, which means your 2 additional steps would be to multiply the radius by 2 to get the diameter. So just be careful. All right, I hope this helps you navigate through your practice for today. See you guys later.